Good day, learners. Welcome to our e-learning class. My name is Mr. Dami. Now, welcome to our physics class. The background to this topic. Today's topic is resistors in series and parallel. Now, the background to this topic, the previous knowledge, you should know about the electric circuits, resistance, and you should know the components in an electric circuit. Now, let's move to today's topic, resistors in series and parallel. Now, what is a resistor? A resistor is a component of the circuit designed to provide a known amount of resistance in a circuit. Now, we all know that resistance is the opposition to the flow of current. So, a resistor is what we use to know that amount of resistance in a circuit. Now, moving on, we have two ways in which resistors can be aligned in a circuit. Now, we have resistors in series and resistors in parallel. Now, let's look at resistors in series. Now, this is when resistors are connected end to end as shown below, meaning they are connected end to end in a what? In a straight line. Now, when resistors are connected end to end, what do? You add the resistors together. You add their resistance together to give you the equivalent resistance, meaning R1 plus R2 plus R3. Now, moving ahead to resistors in parallel. Resistors in parallel is when resistors are arranged side by side and are such that the corresponding ends are joined together at a particular junction A and B, just as shown in this diagram. We have our first resistor here, the second one, and the third one. You can see that they are joined end to end. They are parallel to one another. Now, the equivalent resistance of a resistor in series is 1 over R equals 1 over R1, the first resistance, plus 1 over R2, the second resistance, plus 1 over R3. So that will give us the equivalent resistance of the resistors in what? In parallel. Now, looking at our example 1. Example 1 says 3 resistors of resistance 1 ohm, 2 ohms, and 4 ohms are connected in series. The equivalent resistance of the combination will be what? So you can see they are connected in series to one another, meaning we are going to be adding them to one another. That will be 1 plus 2 plus 4. Then our example 2 says that if 3 resistors, 2 ohms, 3 ohms, and 5 ohms are connected in parallel in a circuit, calculate the equivalent resistance of the combination. You can see we are going to make use of this formula for resistors in parallel. That will be 1 over R plus 1 over 2 plus 1 over 3 plus 1 over 5. So here is the solution to example 1 and 2. Now, this is the diagram for example 1. 1 ohm, 2 ohms, 4 ohms. So the equivalent resistance will be R1 plus R2 plus R3, which gives us what? 1 plus 2 plus 4, and this, the solution is what? 7 ohms. Now, example 2, you can see that the resistors are in parallel, 2 ohms, 3 ohms, and 5 ohms. So we make use of 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R1 equals 1 over 2 plus 1 over 3 plus 1 over 5. The LCMs gives us 30. 2 in 30, 15. 3 in 30, 10. 5 in 30, 6. The summation of that gives us 31 over 30. Now, if you cross multiply, or when you make R the subject, it becomes 30 over 31, and the answer will be 0.97 ohms. So, in conclusion, we have looked at resistors in series and parallel, and resistors in series when they are connected end to end in a straight line. In parallel, when they are parallel to one another. These are assignments. 3 ohms resistors are connected in parallel. What is the equivalent resistance? Then the second one, 4 resistors of resistance 1 ohm, 2 ohm, 3 ohm, 5 ohms are connected in series and afterwards in parallel. Calculate the combined resistance in each case. So the assignment will be submitted by the WhatsApp group, main sequence school WhatsApp number 0811629430. We'll meet in our next class. Thank you.